Good day to you, my dear students. Today, we shall continue from where we stopped in our last class, Chemistry SS2 week 2. My name is S.Adebayo. We shall today talk about the following objectives. We shall be discussing about oxidizing and reducing agents. Last class, we discussed oxidation and reduction. So we want to talk about the oxidizing and reducing agents today. Thereafter, we'll talk about how do we test for oxidizing agents and reducing agents. And thereafter, at the later part, we'll talk about how do we balance redox reaction. I told you that redox reaction is a reaction that in which both oxidation and reduction is taking place simultaneously at a time. Let's look at the oxidizing and reducing agents. The first one is oxidizing agents. What is oxidizing, or when do we say any substance given is an oxidizing agent? An oxidizing agent is a substance which adds oxygen or remove hydrogen from a substance. Excuse me for this. This should be from a substance. From a substance. It should be from, not from. It has a typographical error. Or substance which accept an electron. Don't forget that I told you under oxidation, I said oxidation is the addition of oxygen or removal of hydrogen or acceptance of electron. So whenever we now have any substance that add oxygen or remove hydrogen from a substance, or any substance that accept electron, that particular substance is an oxidizing agent. We shall look at the example. Look at what we have in our slide. The first one is oxidation in terms of addition of oxygen. Let's look at when we see, or whenever an oxidizing agent appears to add oxygen. Look at carbon plus zinc oxide. You can see zinc oxide here. At the right side, the zinc oxide added oxygen to the carbon. Carbon was not originally having oxygen. Look at the right side. Carbon, the zinc that I have now relinquished or removed or given out the oxygen back to the carbon to form carbon dioxide. So that means it's the zinc oxide that added. You can see. So zinc oxide is the oxidizing agent because it's the one that added oxygen to the carbon. And the carbon now has turned to carbon dioxide. You understand? So the zinc oxide is the oxidizing agent. That is in terms of addition of oxygen. Now let's look at this time of the removal of hydrogen. You said that oxidizing agent is the one that removes hydrogen from a substance. It will add oxygen, it will remove hydrogen. Let's look at the second one. Hydrogen sulfide plus oxygen. Look at this now. Hydrogen plus oxygen. If you look at this now, you will see that hydrogen sulfide is at the right. When you get to the left, the hydrogen sulfide has turned to water. And you can see sulfur is carrying hydrogen in the left, but when you get to the right, sulfur is no longer carrying hydrogen. So that means this man oxygen that you are looking at here, this man oxygen has been able, this oxygen has been able to remove the hydrogen from this hydrogen sulfide so that it becomes sulfur here. So this oxygen here is the hydrogen remover. It has removed hydrogen from this man, and you can see this man is no longer having hydrogen again. It has become sulfur in this one. Or look at this case now. Look at this now. In these two reactions, you can see chlorine is an oxidizing agent. Why? The chlorine have taken as a removal of hydrogen. You can say I've removed hydrogen from this H2S, and the H2S now in the right is down ordinary sulfur. So oxygen and chlorine are oxidizing agents because they remove hydrogen from H2S to form sulfur. So that is our oxidizing agent. Something that removes hydrogen, something that adds oxygen. Those are the two scenarios. Now the next slide talks about the last one, which is the oxidation in terms of loss of electron. Oxidation in terms of loss of electron. So the oxidizing agent will gain electrons. The oxidizing agent will gain electron. And let's look at these three reactions. iron 2 chloride, or let's say iron chloride plus chlorine. You can see here, this is iron 2 in the left here, it has turned to iron 3. This is iron 3 now. And you can see, look at it, iron 2 has been able to lose one electron to become iron 3. Because whenever there is a loss of electron, you have the electron changing from, you can see that you have iron 2 down to become iron 3. And look at the chlorine. Chlorine have been able to accept. Chlorine have accepted the electrons, and it becomes the chlorine ion here. So any substance or any substance that gain electron is said to be an oxidizing agent. Look at this, that you can see that the chlorine and iron 2 losses to become iron 3. And you can see chlorine now from 0, you can see the oxygen number of chlorine in this one is 0. And you write to the oxygen number of element in their original natural form or neutral state is 0. And chlorine here now, the oxygen number of chlorine here should be, this is 3, I think it should be minus, I'm coming. This cannot be calculated easily anyway, I cannot, but it's actually more than 0. That's what I want to tell you. If you calculate the oxygen number of chlorine here, it should be more than 0. Because chlorine have accepted or gained electrons from the one lost by the ion. So other means of identifying an oxidizing agent is this, in the substance is one. When you want to know whether there's an oxidizing agent in the substance, any substance that is reduced is an oxidizing agent, or any substance whose oxidation number has decreased. When the oxidation number of any material or any substance is decreased, that particular substance is said to be an oxidizing agent. The oxidation number will have decreased. Okay, let's look at another one, which is the reducing agents. In a nutshell, we say that oxidizing agent is number 1, the one that had the one that has oxygen; 2, the one that remove hydrogen; and 3, the one that lost electron, the one that gain electron, not rather the one that gain electron. When there's a loss of electron, the one that gain electron. So now let's look at the oxidizing and reducing agent in terms of the second, which is the reducing agent. Reducing agent is a substance which add hydrogen to another substance. Don't forget, oxidizing agent add oxygen and remove hydrogen. But the reverse is the case. Reducing agent is the one that add hydrogen, remove oxygen. It's just the reverse of the three we have done as oxidizing agents. Reducing agents add hydrogen. Don't forget oxidation, remove hydrogen. Reducing agent remove oxygen. Don't forget oxidation, add oxygen. And oxidizing agent is the one that have the loss of oxidation number, and here the one that have increase in oxidation number. So let's look at them one after the other. Hydrogen sulfide in this one, look at this one, hydrogen sulfide there. You can see it's carrying hydrogen, and chlorine is the one here. When you get this one become hydrogen chloride, what has actually happened? You can see that the hydrogen sulfide have been reduced to chloride ion or hydrogen chloride. You can see. So in this reaction, you can see that there has been addition of hydrogen to the chlorine here. And what does the addition? The hydrogen sulfide. So it has been reduced. So this is the reducing agent here. Now look at the second example. Remove oxygen. Carbon plus zinc oxide. Carbon was originally at the free state, and we have zinc. So you can see that the carbon has removed the oxygen from the zinc oxide, having CO2 plus the zinc. So zinc here is the reducing agent. The carbon here is the reducing agent because you can see it has removed the oxygen from the zinc oxide. Getting here. Now, in the last one, you said that the reduction is the one that has its oxidation number increases. Look at this equation. Zinc is 0 here, and when you get zinc is +2. The oxidation number of zinc here is +2. So you can say that the oxidation number of zinc has increased. Thereby, zinc is a reducing agent. If to say that the oxidation number of zinc has decreased now, that means that zinc is an oxidizing agent. Just like when we have this case here now, the oxidation number of chlorine here has decreased. Sorry, I was saying increase. This one was decreased because iron increases here. Iron from iron 2 to iron 3, but chlorine from 0 to minus. Chlorine here will be negative number. It will be negative number. That's exactly what happened. The chlorine will be negative number. So the oxidation number of chlorine has reduced. Thereby, the chlorine is the oxidizing agent. But in this case, the oxidation number of zinc has increased from 0 to +2. Thereby, zinc is a reducing agent. Now let's look at some common oxidizing agents, and this table shows some common oxidizing and reducing agents. Oxidizing agents, oxygen, hydrogen peroxide, chlorine. You can study this table and make sure that they are at your fingertips so that you'll not be having issues whenever you want to differentiate, because they can ask you which of the following is not a reducing agent. I want you to get yourself familiar with all this. These are examples. So when you see all this in the reactions, you know that this is an oxidizing agent, this is a reducing agent. That's the table showing oxidizing and reducing agent. Now, let's look at the conclusion aspect of it, which is generally metals are highly electropositive, like sodium, potassium, and magnesium. They lose electron easily, so they are good reducing agents. Any material that loses electron easily are good reducing agents. That is, they release their electrons to another, thus reducing it. Non-metals are the one that are highly electronegative, like non-metals like chlorine, fluorine, and oxygen. They accept electrons. They are good oxidizing agents in terms of that. So any material that accepts electron are oxidizing agents, but the one that release or they lose electron, they are said to be a reducing agent. So please take note of that. Metals generally are reducing agent because they give out. Anything that give out, when they are giving electrons out, they get reduced. But chlorine, fluorine, iodine, which are highly electronegative metals, sorry, non-metals, they are the one that accept, and thereby they are good oxidizing agents. So that's a clue there. How do we test for oxidizing agents? We are going to be using iron 2 salt here with excuse me, we are going to be using iron 2 salt here. Excuse me, let me just off this. We're going to be having iron 2 salts as an example, and hydrogen sulfide. Now, green aqueous solution of iron 2. Iron 2 is green. It will turn to iron 3, which is brown, in the presence of an oxidizing agent. If you want to test, this is a typical test. Whenever you have iron 2, if you add any oxidizing agent, if you have any material, any substance to iron 2, and the blue color of iron 2 turns to brown, it actually means that that particular substance is an oxidizing agent. But if otherwise, that material is not an oxidizing agent. Secondly is hydrogen sulfide. Hydrogen sulfide form deposits of sulfur when passed through the solution of oxidizing agent. Whenever you put hydrogen sulfide and you add oxidizing agent with hydrogen sulfide, there will be a deposit of sulfur. There will be sulfur given out. If sulfur is deposited or given off, then that material is an oxidizing agent. But when sulfur is not given off or given out, that material is not oxidizing agent. It's a reducing agent. Because if a material is not oxidizing agent, it definitely will be reducing agent. And that's exactly what we use to test for the difference between, I think, H2S and sulfur. We'll get to that under our practicals anyway. So these are the two main tests for oxidizing agent. You test with iron 2, blue changes to brown if it's oxidizing agent. We test with sulfur, hydrogen sulfide, it leaves a deposit of sulfur if it's oxidizing agent. What are the tests for reducing agent? We use acidified KMNO4, that is acidified potassium tetraoxomanganate 7 and acidified potassium heptazochromate 6. Now, the purple color of acidified potassium tetraoxomanganate 7 will turn to colorless. So whenever you're adding any material to acidified, I said we use acidified potassium tetraoxomanganate 7, KMNO4. By the time you pour any material into acidified potassium tetraoxomanganate 7, that is actually, this is 7, please, this is 7, not 8, it's a typographical error. That is a purple color. Whenever the purple color changes from purple to colorless, that material is a reducing agent. Secondly, when you have orange color of acidified potassium heptazochromate 6, the orange color, when you pour any material to it, the orange color turns green. If there is a green color, it means that that material you poured is a reducing agent, from orange to green, and from purple to colorless in the case of the KMNO4. Balancing redox reactions. When you want to balance this redox reaction, the following steps are taken. Example will be shown in our next slide, but these are the steps. First one is that you examine the given equation carefully. You balance the number of atoms by adding the correct ions, hydrogen ions or water in the appropriate size. You balance the number of charges. At the same time, you count the number of atoms on both sides charges. If they are equal, they are balanced. You also check the number of atoms and charges. Whenever both of them are equal, they are balanced. Let's look at them practically. Look at this. We are asked to balance this redox reaction. What is the value of n in the following equation? We want to balance it. N makes this equation to be balanced. Now let's look at this. In the given equation, you have the atoms are balanced. Let's look at the atoms. You can see the atoms are balanced. Oxygen, we have 4 here, we have 4 at the right, we have 4 at the left. Hydrogen is 8 at the left. Hydrogen is what? Is also 8 at the right. You can see oxygen is also balanced. 4 oxygen, 4 oxygen. You can see they are balanced. So in terms of atoms, they are balanced. Now, the second is that let's balance the charge. You have to balance in redox reaction. We balance the atoms, we balance the charge because they are carrying charges. So if you look at this equation, look at the left, you can see that the net charge we have at the left is -1. Let's look at it together. The net charge is -1. Sorry, it's plus 7. The net charge is plus 7 because we have -1 on XO4. We have plus 8 on hydrogen. And let's look at this. We have -1. Now, let's look at -1. We have, look at this now. We have two -1. Sorry, -2 here. We have another electron here. You have the net one to be -1 here. We have 8 here. 8. This is 8. So by the time we say 8 minus the net we have here, you know this is plus 1 electron and this is 2 electrons. So 2 here minus 2 here plus 1 here, we have it to be -1. -1 plus this 8. You know this is 8 plus. It becomes plus 7. That's exactly what we have, plus 7 here. On the right hand side, you have 2. We only have 2 plus there. So that means we have plus 7 on the left. We have plus 2 on the right. The charges are not balanced. So what we will do, we now add, we try to add 5 electrons. You know, when we add 5 electrons to we have it to the left. You know, the left has 7 and the right has 2. So we now make sure that we add 5 electrons to the left. When we have 5 electrons to the left, it becomes 2 because 5 electrons will take, that 5 electrons will take, or will neutralize 5 of the positive. Don't get electron and negatively charged. We have 7 here. So by the time you add, by the time you have in this here, you have 7 here, you have 2 here. So if I add 5 electron here, it will neutralize here. So thereafter we will then have 2 at the 2 electron here. You have 2 charges there. You have 2 at both left and right. So what I'm going to do is I'm going to add 5 electrons. So that is why our N becomes 5 here. So it is 5 electrons that makes the whole thing. By the time I have 5 electrons here, the charges are balanced already. Now look at the second one, which is the fact that we are supposed to balance the redox reaction. Excuse me. Cr2O7 2 minus Let's look at the atoms on the left and the right. Let's look at the atom. On the left side, the atoms, we have 7 oxygen. Yes, and on the right, what do we have? What do you have? We have 1 oxygen on the right. Can you see that? We have 7 oxygen here and we have one oxygen here. So what do we do? There's only 1 oxygen there. We balance it by writing 7 at the back of the H here. So on the left hand side, let's look at, there are 7 atoms of chromium. Is it 7? 2. There are 2 atoms of chromium here. And what do we have here? On the right hand side, so we have 1 chromium here, so we have 2. We have to write 2 here to balance it up. So the 7 in front of, we have written 7 here now. The 7 in front of the H2, now on the right side, we give atoms of hydrogen to be 14. By the time we put 7 here, we use it to balance all the oxygen. By the time we put 7 here, it will have made the hydrogen to be 14. And hydrogen here is not just 1. So we are going to write 14 at the back of this hydrogen here. So by the time we write 14 at the back of hydrogen here, the 14 they give the equation to be balanced in terms of the atoms. So what we are going to have, the equation will be balanced in terms of the atoms. So what we are going to do now is to balance the charge. So let's balance the charge, and this is exactly what we have after you balance the atom. Let's balance the charge. When you balance the charge, let's look at, on the left hand side, we have, this is -2 and this is +1. So on the left hand side, what do you have? You have 14 times 1. We have 14 of H plus A, 14 plus H of plus A, and we have this one to be -2. So we have the net charge at the excuse me, it's supposed to be -2 here. So here we have -2 and we have 14 here. We have 14 here. So this, in the left hand side there, we have 12. And here, what do we have on the right hand side? This is 3. We only have charge here. No charge here. We only have charge here. So this is 3 by 2. So this is 6. So we have 6 here. So what do we do here? We now add, at the left hand side there, we are going to add 6 electron, so that the 6 electron will take away 6 of the positive charge in 12, so that will balance the equation. So that is the reason why you have this 6 here, electron here, and that equation is balanced. I think we understand that. So these are some practice questions in case you need to practice. I want you to practice these questions and write them inside your notebooks, assignment books, and when you have issues, let me know. Thank you very much for your attention so far. Now let me just scroll this. This is the first one, 1 to 5, second one, 6 to 12. I want you to practice the questions and let me know anyone you have issue with. Thank you very much and stay safe. Greetings and regards to everyone there. We shall meet in our next class when we shall continue on the syllabus. Thank you very much. Bye bye for now.